This is class 31 of my arithmetic course. Today we're going to review for test number 4. Test number 4 is only going to cover classes 25 through 28, but of course there are going to be concepts that you'll need to know that were covered previously, like operations on decimals, for example. This test is going to cover ratios and rates, proportions, rounding, and basic statistics and graphs. So today we're going to take a practice test to give you an idea of the types of problems that you're going to need to know, even though you already probably figured that out by going through the actual classes. This is just an example of the practice test to get your mind working. And I'm also going to give you a practice test for the homework as usual. The test has 25 problems, and each problem is worth 4 points. But I want you to be aware that the practice tests are not the only thing that you need to study to prepare for the exam, because not every single variation of the problems are on the practice tests. So you do need to go back to your homework, make sure that you can do every type of variation of problem. All right, so let's go ahead and start the practice test. As you can see, we have our instructions as usual. Let's get into it. Number 1. The ratio of Caleb's weight to Jim's weight is 4:5. If their combined weight is 360 pounds, how much does Jim weigh? So the ratio is 4:5. So I'm going to write that down with a colon. Remember, you can write a ratio with a colon, as well as the word to. And their combined weight is 360. So we'll put a C above the 4 and a J above the 5. So C plus J is equal to 360. So what we need to do is we need to find equivalent ratios. So we can multiply the 4 and the 5 by 2, for example, to get 8 and 10. Well, first of all, we can just add 4 and 5 to get 9. Well, obviously, that's not going to get us to 360. So then we multiply both numbers by 2, we get 8 and 10. Add those up, we get 18. So that's 9, and then we get 18. And then we basically just keep multiplying until we get numbers that are big enough to where when you add them, you get 360. So obviously, we're not going to get there very quickly if we just multiply by 2 and then by 3 and then by 4. So I'm going to try multiplying by 10. If we multiply 4 and 5 by 10, then we get 40 and 50. If we add those up, 40 plus 50 is 90. So that's higher, but it's not even close. So let's multiply both those numbers by 30. 30 times 4 is 120. 5 times 30 is 150. Add those together, you get 270. So we need bigger numbers. Let's try 40. Multiply 4 and 5 by 40, and you get 160 and 200. And now if you add those numbers up, you do get 360. And you can do this on paper if you want, but these numbers are pretty easy to add, so I'm just doing it in my head. So this is these numbers, this is the simplified ratio. So all these ratios are the correct ratios, but to get the actual numbers, we needed to multiply or change the form of the ratio to 160 to 200. And these yellow highlighted numbers, they represent the actual numbers, the actual weights of the two people. So Caleb is the first number, and what are we looking for? We're looking at how much does Jim weigh. So Jim is the second number, so Jim weighs 200 pounds. So the answer is 200, and LBS is the abbreviation for pounds. So that's how you do those types of problems. All right. Number 2, we're going to need the information here. So Tom has 7 barley seeds. The masses of the 7 seeds are listed below. We can see here masses of mature barley seeds in milligrams. And number 2 says, for the barley seed data above, find the mean mass, round to the nearest thousandth, the median mass, the mode mass, and the mass range. So let's go ahead and do that. Let's find the mean. So again, we have our data up here. We're looking to our data. The mean is when you add up all the numbers and then you divide by how many numbers there are. So we're going to add up 48 plus 51 and so on and so forth. And I should go ahead and write exactly what we're doing. So mean is the sum of the numbers and then I'm going to divide by the number of numbers, and there are 1, 2, 3, 4, 5, 6, 7 numbers. So I'm going to divide by 7. So I have addition and I have division in this expression. So this is an application of the order of operations agreement. So because I have multiple operations going on here, addition and division, I had to put parentheses around the addition operations because I want to add first and then divide by 7. That's just the definition of of the mean. So in order to make sure that people understand this statement that I just wrote up here, I have to put the parentheses because that means you're going to violate the order of operations. Again, that's just showing people how to write. That's just writing the expression. It's not. There's nothing complicated about that. So let's see here. Make sure I wrote all those numbers correctly. All right. So equals, and then we're going to go ahead and add those numbers over here. Make sure I wrote those numbers all correct. All right, so now we're going to add the numbers in the ones place, 8 plus 1 plus 9, so on and so forth, 18, 19, carry the 1, 5, 10, 15, 19, 24, 29, 34. So it looks like we got 349. Then we take that, so 349, and we divide by 7. So in order to divide by 7, we're going to have to use the long division algorithm because that's a pretty big number. 7 does not go into 3, it goes into 34 4 times, 4 times, which multiplies to 28. Subtract, you get 6, bring down the 9, 7 goes into 69, 9 times. Whoops, that should be a 6. And then we still have a remainder, so we have to add a decimal, bring down a 0. 7 goes in 8 times, which is 56. Bring down the 4, bring down a 0. 7 goes in 5 times, which is 35. Subtract, you got 5, bring down a 0. 7 goes into 50 7 times. And as you can see, this is just going to kind of keep going on and on and on. That's why they told us to round to the nearest thousandth. So it's a good thing that we learned how to round. But anyway, before we do that, we have to figure out where to put the decimal. So you see the decimal here, it goes straight up. So right there, and if you lined up your numbers properly, you can see my numbers are lined up pretty well. If you don't line them up properly, you'll get that decimal in the wrong place, so be aware of that. And actually, we need to round to the nearest thousandth, so we need to put one more number. 7 goes into 10 one time. So there we have it. We have the 10th place, the 100th place, and the 1000th place, and we're going to use this number to figure out whether or not we're going to round up or down. So we want to know if we're going to, the 7 is in the 1000th place, so we want to know if we're going to keep 7 or we're going to round it up to 8. And we look at this number to figure that out. So if the blue number is, if the blue number is 4 or below, you keep 7, and all these blue numbers become 0, or the one blue number becomes 0. But if the blue number is 5 or bigger, then the yellow number goes to an 8, and the blue numbers again all go to 0. So again, we're just trying to figure out if we round up or down. And the 1 tells us to round down. So we have, let me move this here. Move that down a little bit. So we have to write their approximately sign, squiggly equal sign, because it's not exact. Approximately 49.85, and we don't raise the 7, we just leave it. And the other number becomes 0, but of course that's an ending 0 to the right of the decimal, so we don't need to write that. So that's the mean. So that's probably the most difficult calculation when you're doing statistics here, because this is obviously a basic statistics problem. And we cannot forget, we have to write the unit. It's milligrams, so that's mg. Or if you don't know I realize that you may not know the abbreviation for some of these units. So when you do the test, you can just write milligrams. You don't have to write mg. All right, so that was the hard part. The rest should be a lot easier for these. We have to find the median mass. In fact, let's find the mode, because that's one of the easiest. Whoops, I put an equal sign over here. Take that away. The mode. I'm going to separate all this stuff. The mode is the number that appears the most, but why? Yeah, looks like, let's see here. Which number appears the most? 51 appears twice, but 50 appears 3 times. So 50 is the mode because it appears the most. So you have to remember to put mg. So now let's do the range. The range is the biggest number minus the smallest number. The biggest number is 51, and the smallest number is 48. So we don't really need to, I mean, we can do that in our head. That would just be 3 milligrams. So that's the range. And now we need to find the median. And the important thing to understand is that we cannot find the median unless we order the numbers from least to greatest. So we have to go ahead and do that. 48, 49, there's 3 50s, and then we have 2 51s. So now the data is ordered from least to greatest, and now what students like to do is they block off the outside numbers. So you got 1 pair, and then you block off another pair, and then you block off another pair, and then you see we have a middle number. The reason we have a middle number is because there's an odd number of numbers. 7 is odd. 2, 4, 6, 8, those are even numbers. 1, 3, 5, 7, those are odd numbers. So whenever you have an odd number of numbers, you always have a middle number. So that is going to be that's the median. So again, the median is just defined as the middle number, 50 milligrams. And again, to review, the mean, the median, and the mode, those are all measures of the center of the data. The range is a measure of how spread out the data is. And you can see, in this case, the range is not very spread out. It's only 3 milligrams. All right, so that's number 2. We have all our units for those. Everything's rectangled. Number 3, for the barley seed data, find the mass interquartile range and show the distribution of the masses by drawing a dot plot and a box and whisker plot of the data. Then identify any outliers in the data. If there doesn't appear to be any outliers, write no outliers. So number 3 is going to use the same data, the barley seed data. All right, so we're going to find the interquartile range of the barley seed data. You know what, let me copy the data and bring it up here. Alright, so now we got the data in order from least to greatest. So we need to find the interquartile range. So that in order to find the interquartile range, we need the first quartile and the third quartile. So we take the first half of the data and the second half of the data, not counting the middle number, because there's an odd number of numbers, and we find the median of the first half and the median of the second half. And the median of the first half is the first quartile, because that kind of breaks the data into 4 parts. So as you can see, the median of the first quartile is the middle number, which is the blue number, and that's 49. So Q1 is equal to 49 milligrams, and Q3 is the median of the second half, which is the blue number again, which is 51 milligrams. So now we have Q1 and Q3, so the interquartile range, which we notate as IQR, is equal to Q3 minus Q1, which is 51 minus 49, which is 2 milligrams. So that's the interquartile range. And you may be thinking, well, why do we care about the interquartile range? Well, the interquartile range doesn't include the smallest numbers and the biggest numbers. So it's just a different way to find the range. The range includes all the numbers, but the interquartile range kind of cuts the smallest and the biggest numbers off, because obviously, oftentimes the smallest numbers and the biggest numbers are what we call outliers. So we don't want to include those numbers. Outliers are numbers that are unusually big or unusually small. All right, so now they want us to show the distribution of the data. The distribution is just what the data looks like, you know, how the data is spread out in its center. They want us to display that distribution with something called a dot plot. So again, these things should be familiar to you. If you don't remember, that's okay, but this stuff should be somewhat familiar. So I'm going to go from 48 to 51. So 48, 49, 50, 51. So I guess there's only 4 tick marks there. 48, 49, 50, 51. So we make a dot for each. 48, 49, and there's 3 50s, so we have to make 3 dots on top of each other. I'm going to shrink this, put it over here. So 1, 2, 3 dots for 50, and then we have 1, 2 for 51. So that's the dot plot. Very easy. Now we have to they tell us to make a box and whisker plot. I'll have to shrink that a little bit more. Now I like to make the box and whisker plots directly above the dot plot, and I'd like you to do that too. I'd prefer that. So we make a vertical line on the smallest number, a vertical line on the biggest number. Then we make a vertical line for the median, which is 50. And we make a vertical line for Q1, which is 49. And a vertical line for Q3, which is 51. So that's already on top there. And we draw a line through those. And then we draw a box on the middle 3 numbers. So in this case, this box and whisker plot only has 1 whisker. Remember, that is possible to only have 1 whisker on your box and whisker plot. All right, so let's just double check that, make sure we got everything. That looks right. So again, the box and whisker plot just kind of tells you what the spread of the data is. It tells you what the center is, which is here. It tells you where most of the data is. It's spread out along this box here. But then you can see the outliers, they don't necessarily have to be outliers, but the smallest value or the biggest value with the whiskers. It's just a way to display the distribution of the data, to see all the data at once. All right, so now we just have to, it says if there do not appear to be outliers, write no outliers, or if there are outliers, identify them. In this case, I don't see any outliers. 48, I would not consider to be an outlier. So we can just say no outliers. All right, so that was our first stats problem for today. Or we had those two problems are our first stats problems. On to number 4. So don't worry about it. Not all the problems on the test are going to take that long. The stats problems take a while. So don't worry about it. A lot of these problems you can do really quickly. For example, number 4. Is the proportion below true? Now remember, a proportion is when you set two ratios equal to each other. So we want to figure out if these two fractions are equivalent fractions. And all that means is that when we reduce the fractions by using the fundamental principle of fractions, the fractions should look exactly the same. So I'm going to use the fundamental principle of fractions, and I'm going to divide the first fraction, 20 over 25. I'm going to divide both sides by 5, and I get 4 over 5, and I can divide the other fraction by 5 also, and I get 3 over 4. So as you can see, these fractions are not equal. So the proportion is not, it's false. So we can just say no, it's not true. All right, number 5. If the ratio of red apples to green apples is 2 to 5, and there are 45 green apples, how many red apples are there? All right, so I'm going to write that ratio with a colon, 2 to 5. That's the easiest way to write a ratio. And then I'm going to write red apples and green apples, so R and G. That'll just help me remember which is which, because if you get them mixed up, then you're going to get the wrong answer. All right, so 45 green apples. So we need this to be 45. And we want to know, what is this number here? So again, with ratios, I mean, on the above problem, we use the fundamental principle of fractions. We can divide both numbers by 5. But remember, we can also multiply both numbers of a fraction. That's the fundamental principle of fractions. You can divide both sides of a fraction by the same number, or you can multiply both sides of the fraction by the same number, and you get an equivalent fraction. Well, the same is true for a ratio. Remember, a ratio can be written as a fraction. The ratios and fractions are kind of pretty much the same thing. So we're going to use the fundamental principle of fractions just like we did on problem number 1, I believe. And we're going to figure out, what do we multiply 5 by to get 45? Because both 5 and 45, they represent green apples. So what do we multiply 5 by to get 45? We multiply by 9. So we have to multiply 2 by 9, and that gives us 18. So again, if we multiply both these numbers by 9, we get 18 and 45, and 45 represents the actual number of green apples, so 18 must represent the number of red apples. All right. Number 6, solve the following proportions. So now we have a proportion that's, this problem is basically asking, what is n? So there's a lot of different ways to solve these problems. In this problem, the easiest way to do it is just to get 21. This is kind of the same type of problem that we just did. It's just written as a fraction. Number 5 was really a proportion problem. It's asking us, to find the unknown. So what we do is we multiply the second fraction. We use the fundamental principle of fractions again. We multiply the second fraction, 2 over 3. We multiply both sides by 7, and we get 14 over 21. Again, I just used the fundamental principle of fractions. I just changed 2/3 into 14 over 21. I changed the form of the fraction. It's easy. So the big question is, why did I do that? Well, you can see now and by the way, we're assuming that this equation is true. And this problem up here, we didn't assume that the equation was true. We were trying to figure out whether it was true. That's not the case in this equation. In this equation, they're telling us that these two fractions are equal. So we know that they're equal. So if we know that they're equal and now they have the same denominator, that means the numerators must be the same. So we just figured out what n is. N has to be 14. So that's one way to solve a proportion written in that form. You can't solve all proportions that way. For example, in number 7 here, if you try to if you try to multiply 3 by something to get 7, it's not going to work. It's going to be some sort of a fraction. So in this case, we have to use a more high-powered algorithm. And if you recall, when we have a situation like this, the algorithm that we use is we cross-multiply. So we're going to do 3 times 8, and then 7 times n. So 3 times 8 we're going to put on this side is 24. Actually, you know what? I'm going to go ahead and write that out so you can see what's going on. 3 times 8. And then on the other side, we're going to write n times 7. So you're probably thinking, well, why does that work? Well, you don't have to worry about why it works now. That's just an algorithm that you're going to learn more about when you take the next course, which is pre-algebra. But most likely you'll learn more about it in the class after that, beginning algebra. Anyway, 3 times 8 is 24. So now we have 7 times some number equals 24. So what that's asking is how many times does 7 go into 24? Well, that's just a division problem. So I'm going to do that over here. 24 divided by 7. Remember, if the number is next to the letter in an equation, then you always take this number and divide by this number. Most students will just memorize that. 7 goes into 24 3 times, which is 21, remainder 3. It says here, write your answer as a decimal and round to the nearest thousandth. So we need to keep going. 7 goes in 4 times, 28. And just keep going on and on. 7 goes in to 60 8 times. Whoops. 7 goes into 45 times. And it goes into 50 7 times. I think that's all we need. So now bring the decimal straight up. And again, there's no decimal over here in the divisor, so we don't have to worry about moving the decimal over to the right. We just bring it straight up. All right, so n equals 3.42857. It just goes on and on. So it says here, round to the nearest thousandth. So the 8 is the thousandth place. And so we use the 5 to figure out, do we keep 8 the way it is and change all the blue numbers to 0, or all the numbers to the right of the yellow number to 0, or do we raise the 8 up into the 9 and change all the numbers to the right to 0? So, well, the 5 is 5 or greater. It's a number that's 5 or greater, so that means we round the 8 up to 9. So it'll be 3.429. And all these other numbers become 0. Again, the numbers here over to the right of the number in the thousandths place, they always become 0. But because those numbers are to the right of the decimal and they're ending zeros, we can just get rid of those. Again, this is all review stuff. Whoops. So in that case, we do have to change this equal sign to an approximately equal to because we rounded. So we have to do squiggly lines. All right, number 8, estimate the sum below by rounding each number to the nearest whole number, then add the rounded numbers. So I'm going to let you attempt this problem. Of course, you can attempt any of these problems that you want before I do them for you. But go ahead and round those two numbers to the nearest whole number, and that means to the nearest ones place. That's here. It's called the units place, the ones place, or the nearest whole number. Those all mean the same thing. So round those two numbers, add them up, and when you're done, we'll do it together. All right, we're back. So if you round this to the nearest whole number, that's the yellows. And we're going to look to the blue numbers to tell us whether or not to round up or down. So the 3 is less than 5. So we're going to keep the 7, and all the other numbers become 0. But we don't really need to write those zeros. We just write 7. And the blue number on the other number is 9, so that tells us to round up. So we're going to change the 5 to a 6, and all the other numbers become 0. But again, we don't have to write those. So now, as you can see, it's just 7 plus 6, which is 13. Now, if you were to actually add those numbers up, but without rounding, then you would get 7.3909 plus 5.901. You would get 13.2919. Which is very close to 13. So you can see the power of estimation. It just helps us do it quicker. All right, number 9. Jesse has 23 football cards and Marty has 18 football cards. By the way, if you got that problem right, good job. Write the right ratios of these two numbers in 6 different ways. So this is a really easy problem. You're just writing the different forms of a ratio. So 23 and 18. So we can write a ratio with a colon, and we can switch the numbers because it doesn't tell us a specific order for the numbers. It just says use the two numbers to write ratios, so we can switch the numbers. We can also write the ratio with the word 2 and switch the numbers, but be aware that 23 to 18 is not the same thing as 18 to 23. Just keep that in mind. And we can also write ratios with fractions. All right, so those are the 6 ways to write ratios, or to write a ratio with those two numbers. All right, number 10, write the following ratios in lowest terms. So for part A, we just divide both numbers by 3. Looks like we can do. So 6 to 7. And then for part B, we can divide both numbers by 11 and get 5 to 6. So again, we're just using the fundamental principle of fractions, but we're applying it to ratios, because the fundamental principle of fractions works for ratios as well as fraction form, and as you can see, you can write ratios as fractions. So ratios and fractions are pretty much the same thing. Part C, you can divide both numbers by 9 to get 8 over 9. So we're just reducing these ratios to the smallest whole number ratios we can get. These are all equivalent ratios. They're different forms of the ratios. In part D, we just divide both numbers by 11 to get 6 to 5. So that was a pretty easy problem too. So we have the weights of Anatolian shepherd dogs in pounds. So these are the weights over here. Number 11 says, using the data above, find the average weight, median weight, mode weight, and weight range of these Anatolian shepherd dogs, these 4 dogs. All right, so we're going to find the, let's do the easy numbers first. So let's find the mode. There actually is no mode because that's the number that appears the most. So we just say none. Now let's find the range. The range is the biggest number minus the smallest number, so why don't you go ahead and try that. And when you come back, we'll do it together. All right, we're back. So the biggest number is 138, and the smallest number is 50. So if you want to do that out to the side, you can. You could probably do it in your head. 8 minus 0 is 8. 3 minus 5 we can't do. We have to borrow. We give to the 3, 13. 13 minus 5 is 8. So 88. So that's the range of the weights of these Anatolian shepherd dogs. And the units, we got to put units, it's pounds. 88 pounds is the range. All right, so now let's find the median. We cannot, so I'm leaving the mean weight for the end. And be aware also that mean is also called the average. You need to know those two terms. So median, we cannot find the median unless we first arrange the numbers from least to greatest. So we got 50, 110, 119, 138. So now the numbers are from least to greatest. And finding the median is not going to be quite as easy as the other problem because we have an even number of problems. 4, 1, 2, 3, 4 is an even number of problems. And so the reason that it's more difficult to find the median when you have an even number of problems is there is no middle number. So the median is not going to be one of the actual numbers. So what we have to do is we have to use the mean to find the median. When you have an even number of numbers, the median is defined to be the mean of the two numbers that are in the middle. Even though there's technically no middle. So we have to find the mean. We have two numbers. We're going to add them up. And then we're going to divide by the number of numbers, which is 2. That's the mean. So we get 229. And then we're going to divide by 2. And we get 114.5. So the median, let me take this down here. The median is 114.5 pounds. All right, so now we just have to find the mean. So for the mean, we have to take all those numbers and we have to add them up and then divide by the number of numbers. I'm going to go ahead and show what I'm doing here. So mean equals, and I'm going to need parentheses. And divide by how many numbers? Or what number? 1, 2, 3, 4. We have to divide by 4 because there's 4 numbers. All right, so we're going to go ahead and set those up. Remember, you have to line those numbers up properly. If you don't line them up properly, you're guaranteed to get the wrong answer. So we have 417. 417 divided by 4. So now I'm going to go ahead and do that. I'm showing my work kind of sloppy here. You want to be as neat as possible. So I bring down the 1, right? I bring down that 1, and after I bring down the 1, 4 still does not go in to 1. So I have to put a 0 because it went in 0 times. Then I bring down the 7. We have 10. Goes in 2 times. Four times 2 is 8. Remainder 2, bring down the 0. Sorry, this is so sloppy here. It's hard to, goes in 5 times. 4 times 5 is 20. Remainder 0. Bring the decimal straight up, and we get 104.25. Pounds. That's the mean weight of the dogs, 4 dogs. All right. So we have all your units there. So now number 12, using the same data as problem number 11, find the interquartile range and show the distribution of the data, blah, 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 dot plot, box whisker plot, same problem as we did before. So I'm going to go ahead and bring down those numbers ordered from least to greatest, or copy that. So we don't have to keep looking up. All right, so we have to find the interquartile range. We cannot find the interquartile range unless we first find the first quartile and the third quartile. So we have to look at the first half of the data and the second half of the data. The first quartile is the median of the first half of the data. But again, the median is the middle number, but you can see there is no middle number. So we have to find the mean of these two numbers, and that's considered to be the median of the first two numbers. So we have to add those up, 50 plus 110, and you get 160, and then you divide by 2, and you get 80 pounds. So that's Q1. And dividing by 2 is just cutting in half, so you can cut 160 in half probably in your head. It's not really necessary to do on paper. But if you want to, you just do 160 divided by 2, no big deal. Q3 is the median of the second half of the data, 119, 138. But again, there is no median in the middle, so we have to find the mean of these two numbers. We add them up, 119 and 138. And we get 257. Then you divide that by 2, because there's two numbers, 119 and 138. And you get 128.5. Sorry, I'm kind of crunching these calculations in there. It's all squished down there. Try your best to be as neat as possible, but sometimes there's just not enough room on the paper to be neat. That's my fault, not yours. All right, but again, you have to show all your work on these tests, or else you're going to get points taken off. That's just the way it works in school. So now that we have quartile 1 and quartile 3, we can easily calculate the interquartile range. That's just Q3 minus Q1, which is 128.5 minus 80. So we can do that up here. Notice that I'm lining up the decimals. It's really hard to line up the decimal if there is no decimal in 80. But remember, the decimal is, if there's no decimal, it's always to the right of the number in the ones place, which is the 0, so it's right there. We can put placeholders if you want, and go ahead and subtract. We got to borrow. And now we just have to figure out where to put the decimal. So again, when you're adding or subtracting decimals, it just comes straight down. So we have 48.5 is the interquartile range, and we need to put our units as usual. That's one of our answers. So now we just have to do a dot plot and a box and whisker plot. Actually, we have to consider outliers too. All right, so the data is from 50 to 138. So I think we can probably go up by 10 each time. So 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So remember, you want to spread out your data as much as possible. All right, so now we're going to write a dot for each number. And we really don't have very many numbers on this. Remember, statistics doesn't really work unless you have a lot of numbers. So it's really kind of ridiculous to use stats with such small lists. We only had 7 in the previous problem. We have 4 in this problem, but we don't want to give you too many numbers or it would take forever to calculate. So in school, they only give you small lists. All right, so that's the dot plot. So now we're going to do a box and whisker plot. So again, for the box and whisker plot, you have 5 numbers. You want to write vertical lines for each number. You want the smallest value, the biggest value, the Q1 value, the Q3 value, which we calculated here, and you want the median. So see if you can do a box and whisker plot. When you come back, we'll do it together. All right, we're back. So put a vertical line on the smallest value, vertical line on the biggest value, a vertical line on Q1, which is 80 here, a vertical line on Q3, which is 128.5. That would be approximately here, and it doesn't have to be perfect. We're not artists here. We're not trying to make some wonderful work of art. And the median is what was the median? The median was, whoops, I guess I should have scrolled up so you could see what that was. 114.5. So that's approximately here. So then we write a box in the middle part. The middle 3 numbers, we make a box, and then we write lines, whiskers for the other part. So that's the box and whisker plot. In the previous problem, we only had 1 whisker, but in this problem, we have 2 whiskers. So there you go. Now we just have to discuss any outliers. So see if you can see any outliers here. Are there any numbers that are unusually big or unusually small? Well, it seems to me that there's one number that I would consider to be an outlier, and that is this 50. This dog is only 50 pounds. Assuming that these dogs are all mature, and I guess I should have clarified that. Assuming that these dogs are full-grown dogs, it's kind of weird for one dog to be 50 pounds, while the other dogs are, over 100. So I would consider this value to be an outlier. So, and you can kind of see that because the range is 88 pounds, but then when you take the outlier out, the range goes all the way down to, the interquartile range is only 48.5 pounds. So anyway, we can just write 50 pounds is an outlier. And again, try to be neater than what I'm doing here. That's kind of scrunching everything together there. All right, so on to number 13. Estimate the quotient by rounding both numbers to the nearest units place, and then multiply the rounded numbers. So why don't you try this problem, and when you're done, we'll do it together. All right, we're back. So round this to the units place. We have 63, and the other number we have 9. So we rounded up for the first one and rounded down for the second one, and 63 divided by 9, that's one of our products that we remembered, so that would just be 7. So if you got 7, good job. Round the following numbers to the nearest 10. So why don't you, the 10 place is here. So why don't you try those numbers, try to round those, and when you come back, we'll do it together. All right, we're back. So the blue number tells us to round up or down, and obviously 6 tells us to round up. But we have a situation here that's a little weird. See, the 6 tells us to round up, but 9 can't really go anywhere because 9 is the biggest one-digit number. So we have to go up to 10, which makes the 7 go up to 8 because we go up to another place value. So that would be, and we're going to have to use our approximately equal to sign because we're rounding off. That would be 800. All the other numbers go to 0 as usual. But these zeros to the right of the decimal, we don't need to write those. So it just goes to 800. All right, for part B, we do our approximately sign. The blue number tells us to round up or down. So 1 is obviously telling us to round down. So we keep the 9, and all the other numbers become 0. But this number is to the right of the decimal, so we don't need that extra 0 there. And I got to rectangle these answers. All right, so part C, the blue number again tells us to round up or down. 9 is obviously telling us to round up, but we can't round the yellow number. We can't make it go up to any one-digit number, so it has to be 10. So we add a 10, and the other numbers go to 0. So 99 rounds up to 100 when you round it off to the nearest 10. And so now, in the tens place, the yellow, there is no number. We only have a number in the ones place. So the blue number tells us to round up or down. So if we round down, we go to 0. If we round up, in other words, the entire thing becomes 0. Or if we round the yellow number to, if we round up, then the yellow number becomes 1. So 4 tells us to round down. So that would just be 0. So if you got 890, 100, and 0, good job. If you want more practice rounding up or down, then go to the rounding class, and there's plenty of problems. Trust me, plenty of problems on that class. All right, number 15. If a rocket travels 180 miles in 2 hours, how long would it take for the rocket to travel 270 miles? Write a proportion statement to represent this context and use it to solve the problem. So we have 180 miles in 2 hours, and we have 270 miles in we don't know how many hours. So we can just write N. Actually, I'll write H for hours. So we're trying to figure out how many hours. So that's called a proportion statement, and we can use that to solve the problem. So let's see here. What would be the best way to do this? What we can do is divide both sides of this fraction by 2, and then we get 90 over 1 is equal to 270 over n. That's one way to do it. So at that point, we can then multiply both sides of this fraction by 3, and then we get 270 over 3 equals 270 over h. And now, because we are assuming that this equation is true, we know that n must be 3 because the 270s are the same on the top, which means that the bottoms must be the same, which means h must be 3. I think I called h n, I meant h. 3 hours. So that's one way to solve the problem using a proportion. But just be aware that's not the only way to solve this problem. You can also solve this problem using unit rates. So we're not told to use a unit rate, but I'm going to just go ahead and do that just to show you, because it's actually easier to use a unit rate. So now we have 180 miles in 2 hours. That's a rate. And the reason it's a rate, you're probably thinking, what is the difference between a rate and a ratio? Well, a ratio technically is supposed to have the same units. For example, the number of apples that I have and the number of apples that are in the market, those two numbers, if you put them together and make a ratio, you're counting apples. In both numbers are counting apples. A rate is when one number is in one unit and the other number is in a different unit. That's a rate. But again, as I mentioned in the rates and ratio class, that rule is actually broken quite a bit. Ratios are written with different units, so be aware of that. And I think I break that rule in this class also. All right, so 180 miles in 2 hours. So that's a rate, and it's just a random rate. We don't want just a random rate. We want the unit rate. The unit rate is when you figure out how many miles in every 1 hour. The denominator has to be 1 in order for it to be a unit rate. So to find the unit rate, all you have to do is take the numerator and divide by the denominator. That gives you the unit rate every time. You can write it as a mixed number, as a fraction, or as a decimal, whatever you want to do. 180 divided by 2 is just 90. So 90 miles in 1 hour. That's the unit rate. So now that we have the unit rate, we can easily figure out how many hours in 270 miles. Because if it's 90 miles for 1 hour, 90 miles for 1 hour, then if we multiply 90 by 3, we get 270 miles in 3 hours. So 3 hours. So that's just another way to do it. Again, if you need more practice with those problems, you can go back to the ratios and rates class. That was kind of an easy problem, so we didn't really need to use a lot of sophisticated math there. But there are some more difficult problems, which we'll do later. All right, number 16. If the ratio of the total number of red cherries and yellow cherries to the number of red cherries is 10 to 7, what is the total number of cherries if there are 18 yellow cherries? So we have a ratio 10 to 7, and 7 represents red cherries, and 10 represents the sum of the red and the yellow cherries. So it's very important to identify what's going on here. What is the total number of cherries if there are 18 yellow cherries? All right, so this is kind of a puzzle. So if there's a total of 10, then, and we know there's 7 red cherries, at least in the simplified ratio, all we have to do is 10 minus 7, and that gives us the number of yellow cherries, which is 3. So now we have the ratio of yellow cherries to red cherries. It's 3 to 7. Again, this is the number of red cherries, this is the number of yellow cherries. So that's how you find the ratio of yellow to red. Now the problem is going to be easy. So again, that probably seemed confusing, but it really is not hard at all, because you just take 10 and subtract 7. Now we have the ratio of yellow to red. So what is the total number of cherries if there are 18 yellow cherries? So if there's 18 yellow, we have to multiply both these numbers by 6, because I know 3 times 6 is 18. Or excuse me, multiply both, yeah. Whoops, that was the wrong number. Multiply both numbers by 6. And why did I multiply both numbers by 6? Because I know this number the yellow cherries must be 18. And I know if I multiply 3 by 6, I get 18. So I have to multiply 7 by 6 also, because again, the ratios follow the fundamental principle of fraction rule. All right, so the actual numbers that we're dealing with are 18 and 42. So now it's asking us, what is the total number of cherries if there are 18 yellow cherries? So these numbers, again, are the actual numbers. So we want the total number of cherries. We know that there are 18 yellow cherries and 42 red cherries. So we just add those up, and that gives us our final answer. 18 plus 42, and you can do that up here if you want. and it looks like we get 60 cherries. Reduce the following rates to lowest terms. 54 laptops for every 24 desktops. Yeah, it's just like a fraction. You just reduce the fraction. You could use the fundamental principle of fractions, and you can divide both of those numbers by the same number or multiply both of those numbers by the same number. In this case, if we want to reduce, we have to divide both numbers by the same number. So go ahead and try part A and B, and when you come back, we'll do it together. All right, we're back. I know my multiplication facts, so I know if I divide both those numbers by 6, then I get 54 divided by 6 is 9, and 24 divided by 6 is 4, so 9 to 4. So 9 laptops for every 4 desktops. That's the simplified ratio, or the ratio in lowest terms. So if you got 9 laptops for every 4 desktops, good job. I know I can divide both these numbers by 4. Actually, let's see here. I guess that 48 was kind of a bigger number than I thought it was going to be. So I'm sorry about that, but 28 divided by 4 is 12. That's not one of our multiplication facts, so I'm sorry about that, but you can still do it. So then you get 12 miles for every 5 hours is now in lowest terms. So as you can see, that one wasn't too hard. Not all these problems are hard. Find the unit rates for the situations below. You may write your answers as fractions or decimals if necessary. So you can see part A and part B we have rates because they're different units. We have machines, and we have days, and we have yards and minutes. Those are different units. So 35 machines in 7 days, that's a rate. But it's not just any rate. See, we want the unit rate. So in order to find the unit rate, you take the first number and you divide by the second number. That's how you always find the unit rate. You have to remember that for the test. Take the first number, divide by the second number. So 35 divided by 7 is 5. So 5 machines. That gives you the number of machines built in 1 day. That's the unit rate. 35 machines in 7 days is a rate, but it's not the unit rate. 5 machines in 1 day is the unit rate. All right, so why don't you try part B? When you come back, we'll do it together. All right, we're back. So you have to divide 29 divided by 6. Now this is going to be a little bit more involved here. So we can go ahead and do that over here. 29 divided by 6. It goes in 4 times. 24, bring down the 5. Goes in 8 times. 48. Bring down the 2, bring down the 0. Running out of room here, so I'm going to shrink this. And 6 goes into 20 3 times. 18, bring down the 2. Looks like it's just going to be a repeating decimal. Yep, it's just going to go on and on. Bring the decimal straight up. So we have 4.83 bar yards in 1 minute. That's the unit rate. All right. We'll talk about how to write those as fractions probably in the next class. Or after you take the test, we'll talk about that more. I didn't really go into that much, how you write a remainder as a fraction, but we'll go into that later on. For now, probably just write it as a decimal. That would be best. That's one of the things I want to go over more before we end this class. All right, so number 19, draw a bar graph of the data below. Label the graph properly. So bar graphs, that was part of the statistics and graphs part of the course. So let's see here. Our smallest number is 15. Our biggest number is 62. So let's draw that, our vertical axis and our horizontal. We're going to have to make this smaller, I know. Let's see, 10, 20, 30, 40, 50, 60, 70. That should be good. Be sure to label your scale and your units. And we have hamburgers. We can abbreviate hamburgers, hot dogs, fries, drinks, and cotton candy. We'll just put CC. And we have to label each axis. So the horizontal axis is type of food, and the vertical axis is numbers sold. And we have to title. Remember, you always have to title your graph. So the title is just going to be whatever the title of this table is. Food sold at county fair. Again, if you miss some of these titles, for the overall title and the title for the axes, you're going to lose a point for each one that you miss. Like I said in the class where we went over this information, teachers absolutely love to take off points for not titling graphs and marking everything clearly. So hamburgers is 38. That goes up there. Hot dogs is 40. They sold 40 hot dogs. And fries, 41. And these bars should be about the same width, or else it looks funny. I'm trying to make them the same width. Drinks is 62. That's the highest bar. And cotton candy is 15. So there you go. There's the, they should be spaced fairly equally there. I'll move that over a little bit. There's the bar graph. So you can see immediately just by looking at the graph what the most popular food item was that was sold. That's the point of a bar graph, or any kind of graph. You can see the distribution of the data. All right, so on to number 20. If it takes 42 days to build 8 motorcycles, how many days would it take to build 3 motorcycles? Find the unit rate and use it to solve this problem. So on the previous problem, we were using a proportion. A proportion would be 42 over 8 equals n over 33. Or we could say m for number of motorcycles. And then you would solve that with the methods we learned. But they want you to use the unit rate, so we're not going to do that. We're going to find the unit rate. 42 motorcycles in 8 days. That's a rate, but it's not the unit rate. To find the unit rate, we have to take 42 and divide by 8. So 42 divided by 8. 8 goes in 5 times. Remainder 2. Bring down a 0. 2 times 16. Bring down a 0. We go 5, 40. And we have 5.25 motorcycles per day. And I know what you're thinking. How can you make a fraction of a motorcycle? Well, it's possible to have a part of a motorcycle, I guess, but this is not exact. It's the rates, the progress of the builds are not exactly continuous, but we can just ignore that for now in this problem. So now we have the unit rate. So now we want to know how many days would it take to build three motorcycles. You know what? I just realized I did that completely wrong. That should be 42 days for 8 motorcycles. I did that backwards. Sorry about that. If you do something wrong, that's okay. Go back and figure out what you did wrong. So days per motorcycle. 42 days for 8 motorcycles, 5.2 days for 1 motorcycle. That makes a lot more sense. All right, so they want to know how many days will it take to build 3 motorcycles. So this is not easy to figure out because we have a fraction. We have 5.25. But remember, the easiest way to figure out, because if this problem were easy, it would just be an addition or subtraction problem. But because it's not quite as easy to see what to do, we know it's either going to be a multiplication or a division problem. So what you want to do is you want to change this number to something, whoops, you want to change this number to something easier to deal with. So let's say it's 6 days for 1 motorcycle. So they want to know how many, I gotta spell that right. They want to know how many days for 3 motorcycles. So now we can really, this is really easy. So 6 days for 1 motorcycle. Six days for 1 motorcycle. How many days for 3 motorcycles? 6 days for 1 motorcycle. How many days for 3 motorcycles? Well, obviously it's 18. 3 times 18. So how did we figure that out? We multiplied. So that tells us to multiply. So now we go to the actual number, 5.25, and we multiply it by 3. So now that we know it's multiplication, we can do our multiplication algorithm. We don't have to line up the decimals with multiplication. And there's 2 numbers to the right of the decimal, so 1, 2, we have 15.75. So the answer is 15.75 days for 3 motorcycles. That's how long it takes to build 3 motorcycles. All right, number 21, moving right along here. If the ratio of pencils to crayons to markers is 8:3:5, and there are 15 crayons, how many pencils are there? How many markers are there? So this is just another ratio problem, but the difference is you have 3 numbers. So there are 15 crayons. So let's write this down here. 835. The first number represents crayons, the second number markers, and the third number represents, oh whoops, no, that's not correct, sorry. I'm confusing you again. Sorry, pencils is the first number, crayons second number, markers third number. So there's 15 crayons. So the middle number is 15. And we're looking for these other 2 numbers. What are these other 2 numbers? Well, again, you have to understand the fundamental principle of fractions, which applies to ratios also. You can multiply all these numbers by the same number, or you can divide all those numbers by the same number, and you'll get an equivalent ratio. So in order to go from 3 to 15, we had to multiply by 5, which means you have to multiply all the other numbers by 5. So we get 8 times 5 is 40, and 5 times 5 is 25. So these numbers actually represent the actual numbers. This ratio is a simplified form of the ratio, but this ratio represents the actual numbers of the pencils, crayons, and markers. So now we can answer the question. How many pencils are there? There are 40 pencils. And how many markers are there? 25 markers. So that's that problem. As you can see, that was pretty easy. A lot of these problems are pretty easy. It's really just the stats problems that take a while to do. So on to number 22. So we have 4 more problems before we're done with this class. Then you got to do your homework. So now we're going to do a line graph. Draw a line graph of the data below. So that's just going to be another horizontal axis and vertical axis. I want to try to abbreviate here. We're doing dates, 1993, 94, 95, so on and so forth. I'm going to have to move that over a little bit. And we're going to have to make marks down here so we know specifically where to write the dots. And pianos sold, we have 14 is the biggest number. So we have to do 2 each. I'm using the blue lines, as you can see. Whoops, that wasn't right. That should be 14 there. All right, so in 1993 we have 13 pianos sold. 94 we have 14. And just make those dots. Try to be as neat as possible here, but don't obsess about the neatness of the graph. This is not an art class. Alright, so those are the dots. Now we just have to draw lines between the dots. And now we have a representation of how these sales are changing over the course of the years. So that's the line graph, but if you just leave it like that, you're going to lose 3 points. One point that we lose is we have to title the graph. Another point that we'd lose is we have to title the horizontal axis of the graph, which would be year. And another point that we'd lose is we'd have to title the vertical axis, which is number, in fact we should write number here, number of pianos sold. Alright, so that's the line graph there. Alright, round the numbers below to the nearest tenth. Why don't you go ahead and try this problem, and when you come back we'll do it together. Alright, we're back. So this is the 10th place. So we're going to use the number to the right of the 10th place to figure out if we're going to round up or down. I'm going to write an approximately sign because we're rounding. The 7 tells us to round up. The 9 doesn't have anywhere to go because it's the biggest one-digit number. So we have to round this number up, but that doesn't have anywhere to go. So we have to round this number up. We have to keep going until we finally get to here. And this number is just considered a 0, so it has to round up to a 1. And as usual, all the other numbers go to 0. But we don't need these numbers because they're to the right of the decimal, so that number just rounds up to 1,000. It's approximately 1,000. So if you got 1,000, good job. All right, part B. We're I'm going to put an approximately sign. This is the 10th place. The number to the right of the 10th place tells us to round up or down. The 5 tells us to round up. So we go to 80.2. The yellow number goes up, and all the other numbers to the right of the yellow number go to 0. But again, we don't have to write. We don't have to write. We don't have to write that number. We don't have to write the 0 because it's an ending 0 to the right of the decimal. So if you got 80.2, good job. All right, this is the 10th place. We have to look to the numbers to the right of the 10th place. They tell us to round up or down, but there's no numbers there. So we can just consider this number to be 0. So we obviously round down. So the yellow number stays, and all the numbers to the right go to 0, but there are no numbers to the right, so we just write 70 or 770.5. So if you got that answer, good job. Now the 10th place. The 10th place is here. There's nothing there. So we use the number to the right to figure out if we round up or down, and then again there's nothing there, so we obviously round down. I guess I can leave those there. And it would just be 336. So if you got those answers, good job. All right, now we're going to round to the numbers below to the nearest ones place, which is also called the units place, or it's referred to as rounding to the nearest whole number. Go and attempt this problem, and when you come back, we'll do it together. All right, we're back. So this is the ones place. The 6 tells us to round up or down. The number to the right of the yellow tells us to round up or down. So 6 obviously tells us to round up, so we go from 0 to 1, and all the other numbers become 0. But those numbers are to the right of the decimal, so we can just get rid of those, and it just rounds up to 1. All right, part B. This is the ones place. The number to the right of the ones place tells us to round up or down. Obviously 0 is telling us to round down, so we just keep this number, which is 0, the yellow number, and all the other numbers become 0, which means that it just rounds to 0. All right, for part C, this is the ones place. We look to this number to figure out to round up or down. 0 obviously tells us to round down, so all numbers to the right of the 0 go to 0, which means we just have 0. All right, so again, this is the number in the ones place. The number in the number directly to the right of the number in the ones place, that tells us to round up or down. The 1 tells us to round down, so the yellow number stays the same. Whoops. The yellow number stays the same, and all the other numbers go to 0. But we don't have to write those zeros because they're to the right of the decimal. So it just rounds up to 1. So if you got those answers, good job. Or I mean it rounds down to 1, not up to 1. All right, so now we're in the last problem here. 25. If you're hanging on so far, doing good. Looks like we're going to end in a reasonable amount of time today. Estimate and this test does not represent every single variation of the problems. You got to go back to your homework. You got to practice. You can look in any other textbooks that you may have to give practice problems. You can look on the internet. You can look in the classes, my classes, but you got to know how to do every variation of these types of problems. So this is just kind of to whet your appetite with what you're going to be required to do for the test, and give you an idea of what the problems are going to be like. But you got to do everything you need to do to learn every variation of these problems. 25. Estimate the product below by rounding the first number to the nearest 100 and the second number to the nearest 10, then multiply the rounded numbers. So remember, sum equals addition, difference is subtraction, product is multiplication, and quotient is division. So we have product, which of course makes sense because you got your multiplication sign there. So they want us to round the first number to the nearest 100. So why don't you, and the second number to the nearest 10. So why don't you do this problem, and when you come back, we'll do it together. All right, we're back. So this is the 100 place, or hundreds place. There should be an S on that. Actually, no, there. Sorry about that. I'm spacing out there. All right, so that's the hundreds place. And this is the tens place. So the blue tells us to round down. So the yellow number stays, and all the other numbers become 0. All right, now the second number, we're going to round to the nearest 10. So this is the tens place. The second number tells us obviously to round up. So this 5 is going to go up 1 to 6, and all the other numbers are going to become 0. But of course we don't need those extra zeros, like we didn't need these extra zeros over here. So the problem just becomes 300 times 60. So 300 times 60 is pretty easy. It's just going to be 3 times, it's just going to be 3 times 6, which is 18. So we're going to put our 18. And then we have 1, 2, 3 zeros. So there's going to be 3 zeros. 1, 2, 3, we put our comma. So you can see 18,000 is the estimate. Now, again, if we actually multiply those numbers, 326.05, 326.05 times 58.7, then we get 19,139.135. So 18,000 is a pretty good estimate of what the answer should be. It's fairly close. All right, so that was the first practice test. And that pretty much concludes this class. Now, if I rush through any of that, that's fine, because you can just go back and look at your homework for classes 25 through 28, and you can review, and you can watch some of my videos if you're rusty on anything. For your homework, I have another practice test. Let's go ahead and take a screenshot of these 2 pages and a screenshot of these 2 pages. Again, this is your homework. And here's the answers. Take a screenshot of these 2 pages. Be sure to check all your answers. Make sure you do the test properly. Make sure you get all the right answers. And you write them with the right units and right form, and so on and so forth. So doing this practice test is part of your homework, but the other part is actually going back and figuring out anything else you need to know for the test. Making sure that you know every single variation of every problem. So there's a lot of stuff in this course as you're figuring out. We're almost done with the course. I think we have maybe 2 or 3 more classes, not counting the actual final test. The next class is going to be the test number 4. But the good news is you only have to study 4 classes for the next for the test number 4, not including the previous information you have to know about adding and subtracting and multiplying and dividing decimals and fractions and all that type of stuff. So anyway, that's class number 31. So study for the test. Next class 32, is going to be test 4, and I'll look forward to seeing you in class 32.